For centuries, we've gazed up at Mars, the red planet, wondering if it could become our next home. Today, this question is no longer confined to science fiction. With rapid advancements in space technology and growing concerns over Earth's future, Mars is now seen as humanity's backup plan. But is escaping to Mars really a feasible solution? How close are we to turning this barren world into a second Earth? Let's explore the science, the challenges, and the bold visions right here on the Whatverse. Mars is cold, airless, and bathed in radiation. Its atmosphere is 100 times thinner than Earth's and composed mostly of carbon dioxide. The planet's surface is dry and toxic, with temperatures plunging to -80 Fahrenheit. There's no liquid water on the surface, only frozen traces beneath layers of regolith. The soil itself contains perchlorates, chemicals hazardous to human health. Worse, Mars lacks a global magnetic field, leaving its surface exposed to dangerous cosmic rays and solar radiation. Even the lower gravity, just 38% of Earth's, could cause long-term health effects we don't fully understand. Still, one of the most outspoken advocates for Mars colonization is Elon Musk, CEO of SpaceX, who envisions building a self-sustaining city of 1 million people on Mars.
Yeah, and then we'll have the first humans lay the groundwork for permanent presence on the surface. And yeah, the goal, like you said, will be to make Mars self-sustaining as quickly as possible.
But many scientists remain skeptical. To survive on Mars, several proposed solutions have been discussed. First one is domed or underground habitats. NASA researchers, including Robert Zubrin, founder of the Mars Society, advocate building pressurized habitats, either under protective domes or beneath the Martian surface to shield colonists from radiation and micrometeorites. Zubrin's book, The Case for Mars, outlines these ideas in detail, emphasizing modular, expandable colonies using inflatable or 3D printed structures. Then there is the idea of terraforming Mars. It means transforming the Martian environment to make it more Earth-like, essentially reshaping the planet so that humans could one day walk on its surface without a spacesuit, breathe the air, and grow food in open fields. In one of the more controversial ideas, Elon Musk suggested that nuclear explosions over the poles could release carbon dioxide, initiating global warming.
What I was really talking about is creating two little suns, two pulsing suns above the north and south pole of Mars that would warm the poles up enough so that the frozen CO2 would gasify and densify the atmosphere. Some of the water would also heat up, and you'd have sort of more water vapor and CO2 in the Martian atmosphere, which in that case is good because the CO2 ends up warming Mars up.
However, planetary scientists like Dr. Bruce Chakosky from the University of Colorado Boulder, who led NASA's MAVEN mission, argue that Mars doesn't have enough CO2 reserves to make terraforming feasible. His 2018 Nature Astronomy paper concludes that terraforming is centuries away, if ever possible. Then there are talks of closed-loop life support systems, NASA's bioregenerative life support systems research, including experiments at Johnson Space Center and HI-SEAS in Hawaii, focus on systems that recycle air, water, and waste. Projects like ECLSS, used on the ISS, are prototypes of what future Martian habitats would require. Dr. Joya Massa, a NASA scientist leading plant growth experiments in space, notes that growing food on Mars will be critical to long-term survival. The fourth option being researched is in situ resource utilization, which refers to the practice of using local materials found at a space destination to produce supplies needed for space exploration, rather than transporting everything from Earth. NASA's MOXIE experiment, carried by the Perseverance rover, has successfully shown that oxygen can be extracted from Mars's carbon dioxide-rich atmosphere. Despite progress, colonization faces logistical, ethical, and technological hurdles. Some scientists, like Dr. Lucianne Walkowicz, an astrobiologist at the Adler Planetarium, warned that focusing on Mars may distract from saving Earth. So when could we truly colonize Mars? Musk's 2040 timeline is ambitious. Most experts project the second half of the 21st century, perhaps the 2070s or beyond, as more realistic. Colonizing Mars will challenge our ingenuity, unity, and resilience. While it doesn't appear likely in the near future, changing circumstances on Earth, such as climate change and other global pressures, could shift that timeline. If you enjoyed this, don't forget to like, share your thoughts in the comments, and subscribe for more fascinating insights.